Okay, I'm live. Here we go. So let's just finish working on this board. Alrighty, the major change I've done since the last stream is I have made the pads a bit oval shape. It's, it's not mathematically oval, because it's actually an elongated circle. But the thing is that allows me to route two different traces between adjacent paths. That is super helpful for routing the last few traces. I believe that it will be possible to route those without this change, but it makes things so much simpler. And if we hide all the tracks and stuff, you can see that the board is littered with vias, absolutely littered with vias. I think after this change, some of those vias are no longer necessary, and as I heard, that vias will cause signal to reflect, and that will degrade signal integrity. So in this stream, my plan is to try and eliminate as many vias as possible, but that is not going to be easy. Before that, I may need to add a via. How ironic. The first thing I plan to do in this is to add a via and get the get the clock signal over to here. Get it over. Yeah, I can route two traces across. Okay, the benefit of routing the clock through there is that I can have space to place one of these at this place. Of course, that means this has to be changed. Go like that. This will go like that. That's another task of the day, which is to try and fit in, or actually squeeze in a few bypass caps. Sometimes I absolutely love the pushing traces around feature of KiCad. Sometimes you just have to do it manually. Flip it around. What was I? Maybe. Probably. It will probably work. That didn't do much. Hope these filter caps can work. I have absolutely no idea. The biggest problem is whether they will fit. Yep. Sort of. Hopefully. Yeah, I've got a filter cap here. Well, bypass cap, however you want to call them. I may need to reduce one row of prototyping region because I only need 4 to put in a dip socket. So it's not a big deal. Why does it only goes left and right? I am not a big fan of the control of this 3D viewer. It just feels wrong. If I can put it on top there, I don't need any bypass cap down there. And I may just be able to do it. Let's do it here first. Not enough clearance. Yep. Okay, I have 2 choices. Either push this to the left and then place the bypass cap in this empty space here, or get it over. Doesn't look promising, does it? Try the other way around, which does look more promising. squeeze them. No, let's leave that in there. No, it's too weird. Do we need that? No. No. Got one there. Over here. There are some free spaces over here. This part of the board is not very crowded. This is not enough clearance. But we can always just avoid going there altogether. Oh, I'm not expecting to put all these filter caps, bypass caps in. That is actually very surprising. Is that a good place? Or should I just put it here and call it a day? There's already a cap here, so that will probably not do much. So maybe this is better. Hmm. Let's see. Not too bad. I do need one for the clock crystal. And as it is a power hungry part, and it operates at very high frequency. I do have feeding caps here, and one is here. Can we get one close enough for the CPU and stuff? That would be great. Well, it may be possible. Is this enough? What are my constraints? 2.33. On that causes clearance 0.25. Track width is newer ones are a little bit lower in terms of track width. Okay, so this will be the one in charge of CPU and stuff. This part is crowded. This part. This part has the data bus, an entire data bus on it. Around this line. Signal's busy. Signal is so busy traveling through there that I have to use thin traces for ground. I see a few potential routes. None of those are very, let's say, clean cut. We can have a try. Nope, there's no way to build via here. We need to get this IOR via higher. What a pity, this is... Well, this was... such a beautiful line. But this is electrical engineering. How dare do I demand the line look the way I like it to? Oh, this looks like a unused opportunity. Thin power lines, definitely not a fan of those. You just have to do that sometimes. I have freed up the space for a via. And I need a space for a trace. Damn it. Can be obtained. By routing B2 through a less crowded region. I'm trying to deal with you. Now you're causing me trouble? Well, that means I've been on the wrong side. Looking good? Oh, this is not very necessary. It doesn't simplify things by a lot. Oh, D4. Also known as the line that caused me an infinite amount of trouble. It's rather like that because both this gap and this gap have two traces routed through them. But that's a problem that can be easily solved. Easily enough. And there's a via here. Where is D4? I'm not a fan of being D3 being like this. I'll move it elsewhere. Well, the simplest way is I can push it. And that'll be enough space for the stuff. But D3 has a chance to go there. Hmm. Hope I saved a few years. Yes, doing cleanup. Ooh, we can give this to there. But here, we have a chance. If only there's a key in like keycad that allows you to kind of like summon a bypass cap right with the press of a button. So I want a bypass cap here. Alt C for cap. I'll just give you a cap and automatically add that to like Sketchmatic and everything. Move it. I very seldom use the move function of keycad. I'm not. I'm not expecting to use up all the bypass caps. That is nice. We've got like around 30 maybe bypass caps. Are there this many? Some of those are the big electrolytic ones. And I have around 40 chips. I read in a textbook somewhere that you need around one bypass cap for each 3 to 5 chips. However, I understand that is only if you can place those next to them or something like that. Whenever route you like plan one bypass cap space for those chips or something. I think the best way is to probably route it on the front. Because we need to get it to here, which is blocked. Both front and back. I really want that cap to be able to filter the current for these chips. VY people soldering by hand YouTube. U32 lead spacing. What is U32? Is the U32 on the board? Oh yeah, this one. I'm not quite sure. I can change it. It's a 7905 regulator. Yeah, I can probably just change it. To something more sane. TL92, let's do a tap down, tap up. Let's do a TL220. Wait, I did not place C26 on the board? Okay. Okay, we got one free cap. I am definitely making kits. So any suggestions about footprints that will be hard to solder will be very helpful. Wait. Make me a smaller footprint, Nintendo. The thing is, I work with Nintendo Entertainment System boards. If you look at the Japanese version, the Famicom board is basically packed with chips. So, I'll give you a problem. Basically, if you want to go any smaller than that, you will need to use like a surface mount. Yes, then probably the CPU and PPU are dip 40, so those will be the biggest part on the board, but it doesn't matter anyway because the cartridge slot is a dip. It's a not dip, but it's 2.54 millimeter, 0.1 inch spacing part, and the Famicom has 60 pins and NES has 72 pins. So that thing will determine your board size. TO92, huh? TL92L inline wide. What is that? It doesn't count as default. The problem is, wait. I need to pause the stream for a moment. Top loader. I probably know how that device will look like, and that analog made a device that's FPGA based. That's essentially a top loader Famicom or NES or maybe SNES. It's like 3-in-1 thing, and that's quite small footprint. Don't know whether that's what you're about. Hmm. What's the faster way to? Yeah, this is the fastest way to get. Data sheet for that. Wait. You am I crazy? Am I crazy, or is the pinout different between 78 series regulator and 79 series regulator? 1, 2, 3. Come on, what is 1, 2, 3? Wait, what? I only said. Yeah, different. Oh. 1, 2, 3. 1, 2, 3. This is it's ground in the middle. And for the 79 ones, I was like, ground on the side. Okay, fine. Fine. I was about to say I've been using linear regulators for years, and I swear that they would have ground in the middle. Okay. I guess just not this one then. I want to maintain a healthy clearance. Between the regulator and the filter cap. And that is because more than once, absolutely more than once, was a device killed because the filter cap is too close to the regulator, and it is heated and the electrolyte dry up, or it will expand and leak or something. So that is one of the concerns. However, the minus power rails are almost nothing. They carry almost no current. They carry effectively no current. So it's not that big a concern. Okay, these zeros giving me trouble. Top loader cartridge connector for the NES. I never checked for that. That is great. I may do a project with the NES slot sometime. That is nice. So, Comedy Flu. Do you do like an original NES, just smaller, or do you like some hardware enhancements? I know people have their preferences about whether to use enhanced hardware. Personally, I'm kind of leaning towards, if you are going to build something new, there's no reason why not, say, just add a additional sound chip to your build and make it maybe a little bit more powerful than the original. Of course, that comes with the problem of like what software or games will use that hardware. But the rule of the community is basically, if it's there, people will use it. People use like very rare prototype hardware to code games. Like I've seen games that will only run, for example, on MSX with a graphics 9000, and there's probably less than 1,000 of those uh, enhanced graphics cards floating around in the entire world. Got a Command X16 clone recently. Oh, is it the open source Commander X16? Like the mini ITX one? Is it? Other for you, U30. Yes, this is the type of community input that I desperately want to go into the project. I've been following the X16 long enough to know that it's kind of a dumpster fire recently, and I desperately want to avoid repeating the mistakes that the Commander X16 experienced or like the team had made. I want to avoid those mistakes. The other X. Is it the other X or the older X? Or older X? Or others? How to pronounce that? Can you send me a link to the older or gosh older X? Other, like an animal. Okay. That's one blind spot of me. I don't know a lot of animal names in English. Yay. Uh-huh. I need to tidy up the lines crossing here. Or maybe I can just move the via to here. Oh, the A8 is there. That won't work. But anyway, we can get our big fat ground line there and maybe have enough space to do another two vias. Other X. Okay, oddity. Okay, thank you. Okay. Look at this part of the board. What do you find standing out? I'm going to turn off the tracks. I'm going to turn off the pads. Or turn them back on. What I'm getting to is that there are 4 mounting holes here and a connector here. Wait. Yep, 89.5 millimeters. So this, and if you can check the pin out here, this is the space for a Vera module. Yep. Other than the Commander X16, U42, okay. This is the second computer, well, and the other X to use the Vera module. And that's basically because I originally want to put a V1958 on the computer. And as you can see, there's not enough board space for that. And I break it out to a separate module. Has Wi-Fi, nice. Does it still use the same pinout? Because each device on the bus have a maximum of 32 ports for access, no more. That's a hard limitation of the architecture. And I kind of expanded from 16 to 32 just for using the Vera because it uses 32 ports. And this board once had a CF card slot for storage and a YM2203 FM chips for sound. And then it became a bit too much. Because this is already horrendously complicated. So I was like, oh. I was like, more chips? Nope. And the Vera kind of solves all those problems. It has storage, it has sound, it has graphics, and obviously now has and then now has Wi-Fi too. Yes means it uses 32 ports for interfacing, right? Great hole spacing. Okay. What does that mean? Oh, U42 too close to H2. Yeah, that's one of the old concerns. The place for H2 is fixed. It's like hard fixed. Because this is an MATX board and you just don't change the place for your screw holes. Now U42 was placed back when I was using a 0.05 inch grid. Now I can move it maybe to this a little bit. Okay. The interrupt request lines are touching, these lines are touching. It's not hard. This is far from the most crowded part of the entire board. I should reroute this whole part. This is just a show of how inexperienced I was when I was routing this part of the board. I've gained so much experience with PCB and stuff when routing this board, and that means since routing this part. This is probably the closest I can make. If I drag it, because then there's not U43, J43, U43. Why is it J43? Let's check this part. It's not going to be a problem. U43 cannot move. U43 is too entangled into the board that I would change a lot of things before trying to move U43. And I am experienced with dip chips enough that I would say with some confidence that U42 and U43 are not going to conflict with each other. I know dip 40 chips kind of extend out of the socket a little bit. But then on the side, U42 will recess from the edge a little bit. Rotate U42, put under H2. Try that before. It won't fit. I remember it being too close to the edge. Yes, well, this is what it will look like. And it's not much further from H2. Let's see. Going to say 0.02 inch to the right. It will probably not interfere with H2. But it will clear U43. I mean, if this whole part just doesn't work, like anything in this part of the board, well, other than the power connector, can just be deleted without affecting any part any other thing on the board. This U42, a U43, this big dip 40 here, is a keyboard controller, as the one you would find on IBM PC80. So it's an 8042, or any of its clones. It controls the PS2 keyboard and mouse port here. And the U42 is open collector inverter, because the PS2 port use open collector interface. So these two are just for the keyboard. And there are some spare pins that are, according to OS dev, readable through a command into the 8042. So I hooked them up to this, which is probably easier to see on the 3D view. This is an NES controller port. I did not choose the SNES port because SNES port is wide. This one is a bit more compact. But the benefit of that is it does not require a lot of GPIO pins. As long as you can bit bang a few bits, you can control an NES controller. However, on the side here is the universal connector of the computer. You can plug an Atari connector into it. You can plug a Commodore connector or Amiga connector controller into it. My AD times on the PS2 keyboard. Wait, I think the official one also used the AD Tiny to talk to the PS2 keyboard and mouse. That's one of my pet peeve or something. I don't know. So one of my complaints about the X16 is that you use a microcontroller to talk to the keyboard and mouse. Nice, fine. You use an I2C to talk to that microcontroller, and that is bit banged from the CPU. And have anyone know the hardware of the Commodore 64? Anyone in the chat know the hardware of the Commodore 64? The Commodore 64 inherited the IEC port from the VIC-20, which is a bit bang port, which is super slow. And this is kind of like that. It is 8 times faster just from a CPU perspective. And I bet the IEC is not the fastest the C64 can bit bang because they are fast loaders. But still, the design just screams an ad hoc solution. And the Commander X16 is a typical case that you cannot afford an ad hoc solution. Why not have USB ports? The problem is the AT Tiny doesn't have a USB host. That's probably the issue. If they're going to have a USB host, maybe they need to put in a Raspberry Pi Pico or something. Genesis controller adapter, yes. I think Master System or Genesis will plug in and function limitedly. They have internal pull-ups which may mess up the signal, but the thing is this: they have a select pin. The select pin on this motherboard is just pulled up. So that won't work. So that the select won't work means you have a limited number of pins that you can use. A limited number of buttons that you can use. Another thing that will work with it is the Kempston joystick of the Sinclair ZX Spectrum. That joystick is basically an Atari with 2 additional buttons. But not a lot of games use that. But I think the Kempston joysticks support 3 buttons, and this one also supports 3 buttons. There's also the Amstrad joystick. You can use the Amstrad joystick on this thing. But Amstrad joystick supports a Y splitter, which this one doesn't. It only supports 1 joystick. And there are absolute weirdos, like the ZX Spectrum Plus 2 joystick. This one also supports it. What other kind of thing will plug into a 9-pin board? Paddles. This thing will not support paddles. AVR USB. Big Bang USB. Okay. I would believe it. The original USB is 1.5 megabit, which is obtainable with bit banging, probably. Yeah, this thing does not support paddles. It supports only digital joystick. But if it's a 9-pin connector, if it's digital, this thing supports it. And now here's the kicker. I think that's how people say it on YouTube. This is the point, because on this computer, your program is running in protected mode. Your program are supposed to call the system to read the joystick for it. So whatever kind of joystick you are plugging into that port, if you set in the system accordingly, it will repeat up, down, left, right, fire button, everything back to the program. All the same. The program just does not know what type of joystick that's plugged into it. That's why I include 2 completely different kinds of joystick port plugged into 2 completely different chips that use 2 completely different protocols just to demonstrate it. Basically, if the system kind of detects or the user sets the system to use like the NES joystick, it will bit bang the NES joystick. If the user said like I want a Atari joystick, the system will use an Atari joystick. If it's a Sinclair joystick, it will use a Sinclair joystick. Everything all the same. User program, the game, everything just works. 9-pin problem. Do you know how many 9-pin mouses are there? I have one Amiga tank mouse. This is the port. This is an Amiga tank mouse. It has 9 pins. And is absolutely incompatible with the PC 9-pin mouse. But it's digital. Problem is, this thing requires a super high polling frequency. You need to be constantly reading that port to know where the mouse is. Now this is a mouse. This is the mouse for the Commodore 64. I bet it also works in 128. This is the craziest mouse protocol I've ever seen. It also uses 9-pin. It's a paddle. This thing emulates a paddle. So yeah, this is another 9-pin peripheral that's digital but analog. I would love to do a video about how analog paddles are actually rad. They are not potential dividers, because those were expensive back then. Like ADC voltage reading circuits was expensive back then. It's a timing circuit. It uses RC timer, and this thing emulates an RC timer within it. Now this is another mouse that doesn't plug into a 9-pin port. So that is nice. That's the mouse port. But other than that, I think we have one more cap to place before we finish today's live stream. Maybe I want to place it there. Just some additional filtering. Alright, so I mean, just make the other X team the official dev team for the Commander X60 already. I mean, it sounds like almost all the development is being done by that team now. Although, why did he quit? Why did he make his own board? Yay! One more filter cap. One big one. Just throw it somewhere. Let's just try finding a place to throw this. Let's just throw a dagger and place this cap where it falls and call it Daggerfall. And this is me making a Elder Scrolls reference. And it's a game that I'm not even played. Gosh. Probably the best place is here. There's already one here, so not that far away from me, nice guy. Oh, absolutely. You have monthly retro computer meetup? Delete 2 rows of prototyping regions. I mean, what a place to live in. Monthly retro computer meetups. I live in Cambridge, and like half of the entire UK retro computing history just literally happened here. And we have an annual retro computer meetup. So, yeah. I don't like to place my component too close to the edge of the wall. I struggle with these. Maybe I should place the cap a bit closer. Does it even matter? I mean, I can drag. How many chips I can place in here? I cannot place any dip 20s. I will not try and place dip 20s here. Well, I can place dip 20s here. 2, 3, 4, 5, 6, 7, 8, 9, 10. But not in this way. Probably, it will probably work. These prototyping regions are just for the really bad situation. So it's probably fine. Let's just ground the screw holes for no apparent reason at all. Just because if we turn off all of these, Yeah, no more red lines. Come on. What is this? Nice. Yeah, no more red lines. This board is finished. Ren Isaac, I saw your project. I bet I bet I saw your project. I'm researching a lot of Raspberry Pi Pico stuff. Look, all of these. This is Cambridge local stuff. All of these are Raspberry Pi Pico stuff. And that's for a project I call PicoMem, the Pico Memory Emulator. I calculated if I use the PIO running at a full 133 megahertz, I will be able to emulate just fast enough a EEPROM or SRAM. But I wanted it to be a sort of persistent memory that every time when you power it down, will save the contents into EEPROM. But then I found it not very practical because you need to tell the Pico beforehand, like you're powering down, so it won't work like that. But what I can do is to emulate SRAM that has content preloaded every time it boots up. So that's cool. So it's like it can be a font RAM. So somewhere between a font ROM and font RAM, it's like I can boot up the computer and will load the default font. But the CPU can load font into that part of RAM. But if that is not the default font, every time it boots up, it needs to be reset. It needs to be reloaded. But that's a quite cool use of that. Drop the Pico use ESP instead. Okay. Is the ESP faster? I will show you something. I love Scotch. There is a connector here. This is my Vera header, and there is this connector here, which, if we go to the 3D viewer, is here. It's a 28 pin header, and that thing is just directly connected to the ROM slot. You can see all these pins just directly go to the corresponding pins on the ROM. This is a EEPROM slot squeezed and condensed into 2 rows like this. So the plan is I can either plug in the ROM or I can plug in a ribbon cable into a ROM emulator. That's the current plan. So if your emulator project is finished, may you add support to connect just the ribbon cable? Because the ribbon cable interface is what I'm planning. The current ROM emulator use like a probe that will plug into the EEPROM slot, which is kind of hard to find. So I designed this so that I can use a common ribbon cable, 28-pin ribbon cable connector. So, does your project support that? Oh! There is a RAM chip. Okay. Okay. So, does your board just plug into a EEPROM slot? That's the question. And can you get power from like the emulated EEPROM connector? .3 volt or 5 volt? Is the IO 5 volt tolerant? Because this is standard 5 volt IO. It will probably work. Won't it? Yes, 5 volt tolerant. Nice. Wish your project success. Andy out here. And thank you all for chatting with me. This has been a nice stream.